Hi, namaste, dear Sati students. I am Priyanka Rajeev from the Department of Mechanical Engineering, IIT Kanpur. And this is lecture 4 of Laws of Motion. And today we will be discussing about Newton's third law of motion and free body diagram. So far we have learned about Newton's first law and second law of motion, where, first law was first law and second law was talking about external force and how it is causing the motion of the body, and third law talks about the tries to answer the question in the following manner. For example, there's this discussion that is given in our NCERT textbook regarding the forces, the external forces that is acting on a body. For example, if you're considering an object like this, which is being pulled by the gravity of Earth, and the question that is being discussed in the textbook is like, is this body is also acting a force, applying a force on Earth in a similar manner? And Newton's third law says that yes, it is also exerting an equal and opposite force on this object, like the opposite object, that is Earth. So when we want to discuss about theorem, we will be first stating it. So what is the statement of Newton's third law of motion? It is, to every action, there is always an equal and opposite reaction. This is a very crisp and beautiful statement that we use it in our everyday conversation also, right? When you want to talk about something of, okay, you are getting what you deserve, in those kind of scenarios also we will be using it anyway. But what it states and the way we are reading it and interpreting it has got a lot of misconceptions regarding it. For example, in the statement you can see there are two words primarily being described here. One is action, another one is reaction. So what is action and reaction? Action and reaction are the names of two force, right? It denotes force. So action is action, reaction is force. Okay, so why we are stating it as with two names? It's because this is like in our real world, force exists in pair. That's what is being mentioned in this Newton's third law of motion. That is the essence of this law. It states that forces always occur in pair, and this pair of force, this if you take this one pair of force, it is always equal and opposite. So this is called as action reaction pairs. Action reaction pairs. So action reaction pairs are the pair of force that occurs simultaneously. It's not like action is the cause of reaction, or reaction is formed as a consequence of action. It's not like that. When action occurs, reaction also occurs at the same instant. Okay, so action reaction pair is the pair of force which is equal in magnitude and opposite in direction. So another misconception about this is, if two pairs always occur simultaneously and they are equal in nature and opposite in direction, then why are they not getting cancelled? It's because, see, there is this force that is acting on this block which is kept on the ground. Okay, so there is this force that is being exerted by this block to the surface, and that is called this force is actually acting on the contact. Okay, so if this is the contact, so this force is acting the contact surface uh, to the surface, and there is this another reaction force which is called normal force, which is exerted by the surface on the body. So you can see this pair of equal and opposite force is acting on different bodies. For example, the so-called action is a force that is exerted by the body to the surface or the floor, and the reaction or the normal force here is exerted by the surface on the body. So that is why it is not getting cancelled, or the effect of force is still prevailing. So that is what. So the misconceptions that we are clearing here is, first of all, forces always occur in pair at the same instant. It's not like there is no cause effect relation implied in the third law. Okay, there is no, like, one is not a consequence of the other. One is not due to the other. It is always occurring in pair, and they are equal in magnitude and opposite in direction. So this is what is about third law. So to explain this, we will see one example. So what is the example? Consider this two bodies, A and B. Okay, these are two spherical objects, A and B. So initially, A is moving at with a velocity of 5 meters per second, and B is at rest. Okay, and then A collides with B. Okay, this is the collision part. So this is the collision part. So A is colliding with B, and what happens here is some kind of so this is not velocity vector. Okay, let me clear it for you. These two arrows are not representing velocity vector. That we will talk about it in a minute. So this thing you can consider now. This is like A and B is colliding, and what happens next is A comes to rest and B starts moving at 5 meters per second. So this is something called as elastic collision. We will be learning about it in the next chapter. So elastic collision is where the momentum is conserved. So momentum is conserved means initial momentum is equal to final momentum. So initial momentum of the system will be equal to the final momentum of the system. So initial momentum, you can see if the this body is having a mass ma, and this is having a mass mb. So initial momentum is something like ma times 5 meter per second, and final momentum is mb times 5 meter per second. This is a situation where ma equal to mb. So you can see that initial momentum and final momentum both are equal. Okay, so this is something called as elastic collision. Okay, we will be learning about it in detail in the next chapter. So for now, we can see some this. We can observe what is happening when this body is colliding with each other. Okay, so what is happening? Initially, or the object A was moving with a velocity of 5 meters per second, and it comes to rest in the after colliding with mass B. And what happens to mass B? Mass B was in rest, and it starts to move with a velocity of 5 meters per second. So obviously there is a change in the state of rest or state of motion. So according to Newton's first law, there is an external force that is coming into play here. Okay, so first, what was the thing that was happening? Mass A stops, or mass A changes its state of motion to state of rest, and mass B changes its state of rest to state of motion. So there is an external force. So what is that external force? So you can think something like, when it collides, this object A is pushing this object B. That you can imagine, right? Like so if you imagine, for example, your friend is standing somewhere and you're going from behind, and as a part of some silly prank, you are just pushing him or her. So that person will move. So similarly, this object is colliding with this body. It's like a push given to that body. So let's call that push as FBA. FBA means force on B, force acting on B due to A. Okay, that is FBA. So this FBA is what is causing this motion of B moving with the uniform velocity of 5 meters per second. Similarly, you will see this object A comes to rest. That means something is reducing its velocity to 0. So what is reducing its velocity? Obviously, there is an external force. What is that external force? It's due to object B. It's due to B acting on A. Like, for example, it is imagine your friend is like you are running, like during running race. You can imagine during running race, what happens is if you are about to reach this final position, like this is the finish line, and you will be running and reaching here, and due to the momentum that you're having, you won't stop suddenly at the finish line. You will move a bit more, right? And imagine your friend is standing here. Okay, you are A and your friend is B, and your friend will be holding you. So what happens is your friend will move a bit towards backward, towards your line of motion, along your direction of motion, and slowly he will also try, he or she will be trying to stop you. So eventually you will come to halt. Okay, so that will be happening. Similarly, this B is trying to stop A with a force FAB. So this FAB is a force that is acting on A due to B. Okay. So according to Newton's third law, what it says, it is FAB equal to FBA. And you can see the direction of FBA is towards from left to right, and direction of FAB is from right to left. So FAB and FBA are opposite in nature. Okay, opposite in direction, and magnitude wise they are the same. So this is what is happening in this situation where two objects are colliding. Head-on collision is happening, and you can see how we have described this scenario with the help of Newton's third law. Okay. Now, another concept for solving problems related to this force and acceleration and everything due to this object is called free body diagram. So free body diagram is to analyze all the forces that is acting on the object. So how to know that? So you can so the free body diagram, the definition is like, it's a diagram of a body representing all the forces acting on it. So you will be getting a sketch of all the forces acting on it, and depending on the direction and the magnitude, you can compute the net force, and then the acceleration caused by the net force, and etc., etc. So imagine a block which is resting on a smooth surface. This red line is a smooth surface. Okay, and this is a block of mass m, which is resting on the red surface or the smooth surface. So you want to know what are the forces acting on this block and on the surface. So you can see that, for example, this mass has a center point, if you imagine, of this rectangle, the geometrical center I'm talking about. Since the mass is uniformly distributed, this center of gravity and center of geometry both will be geometrical center both will be equal. That center of mass is a concept that we will be learning in the next chapter. So for in simpler terms, we can explain like center of mass is a point which you can imagine as something where the if you're applying one force, you can imagine that this whole object as a point, and that force being acting on that point. So that point is called center of mass. Okay. It's like this whole rectangle. You don't need to consider if this force acts here or here or here or somewhere else also. You can always imagine that force is acting on a point like this. So that point is called center of mass. This comes as a consequence of thinking the body as rigid. Okay. So this is not that important at this point of time. Just imagine that this is a geometric center, and you are considering a force mg that is acting on this body. Okay, so mg is a force, as you have learned in the previous lecture. Gravitation force is a non-contact force. So even if this body was in air, it was like suspended in air, or if it was somewhere else also, due to Earth's gravity, this mg force is always acting on that object. Okay, so you don't need so this mg force in the frame of reference of Earth is always a constant force on acting on every object. So m is the mass of the object. Okay, so this mg force is acting on this body, and when you keep this body on a surface, this suddenly a force will be coming into picture. So that force is called N. Okay, let's imagine that force is called N. Okay, so what I was saying is, or we can take it as F for now. Yeah, so what I was saying is, so if any block of mass m in the frame of reference of Earth, like in the vicinity of Earth, or in the Earth's atmosphere, or in the on the Earth's surface, will always experience a force mg. Okay, and so that is a no contact force. So even if you are not placing this block on a table or a floor, or if you're suspending it on air also, this mg is a force that is always acting on the block. Now, when you keep that on a surface, like on a table or a floor, this block will exert a force on the surface of the body, that the table or the floor. So that force we are taking it as F, and due to this this force, you can see that it's not moving. Right, this block is not moving in vertical direction, right? So you can see that it cannot push this force, right? It cannot push the surface with the I mean, it's pushing, but it cannot move the surface vertically downwards with this force. So that means there is a reaction force that is being provided by the floor on the body. Let's take it as N. Okay. So you have seen what all forces are acting now, right? So what is acting? First, there is a mg is a force on every object that is on earth. So despite of it being on the surface or of some floor or hill or table or in a car or anywhere, even if it is suspended on air, or if you're throwing object up in the air also, this mg force is always acting towards the center of earth. So that is always there. And when you're keeping this body on a surface of a surface, suddenly a contact force will come, that is called F. And due to that F force, you can see that the block or the surface is not moving. That means there is an equal and opposite force being given by the floor to the body, that is the normal force, or N. Now we will see the FBD of, or free body diagram of the block. Okay, so what we have seen, there is a mg force which is acting vertically downwards, and there is a N force that is being applied by the surface to the block of mass m. Okay, then now you can see the FBD of the surface. FBD of surface. So this is the surface. So you can see this block is exerting some force, that is F. Okay. How you can say that this N is equal to mg? It's because net force equal to mass times acceleration. Here acceleration equal to 0. So net force is mg minus n equal to 0. So mg equal to n. That is how you know that these forces are equal. Now let's see some examples on how to find, draw the FBD of some arrangements. Okay. So how to draw this thing? Let's imagine there is a block which is on a smooth surface. So this is a smooth surface. So above that surface there is a block of mass m2, and above that block there is a mass of there is a block of mass m1, and so these are resting. These are in a resting state of rest, right? So M1 is in state of rest, M2 is in state of rest, and the surface is also the state of rest. So let's see intuitively what are the forces that is acting here. So you can see that M2, okay, M2 is exerting some force on force to the surface. So first of all, we can see that M2 has a weight M2G, and M1 has a weight M1G, which is acting downwards. Next is what? These two exerts a force F to the ground, and this surface exerts a normal reaction to M2 from the ground. And what else is there? This M2 will exert a normal reaction N21. We will see draw it once again. So this is N2S. Okay, this is F2. If FS2, because it is acting on the surface from the body 2. Okay, and N2S is the force or the normal force that is acting on 2 due to surface. Okay, and there is another force which is like N21, which is the normal force due to 2 on 1, and there is a force which is exerted by 1 on 2. Okay, so now we will see individually the free body diagrams of each of the blocks. So how to see that? We can draw this M1 first. So how M1 is drawn? So first it is M1G is there. So that is the weight of the block acting downwards. Then this N21 is there. That is the normal reaction by 2 on 1. Then what about M2? M2 also, you have something similar, which is M2G, which is acting downwards. And from the surface, you have N2S. And this block is providing the above block. So you can see this block, right? This force is being given by M1 on M2. So that also you have to draw. So that is also acting downwards. That means you can add it over here. Okay. Now on surface, you can see only one force is acting. That is FS2. That is FS2. So this is the force that is acting. Okay. So this is how you see the free body diagrams. Okay. I hope you understood this thing. So first you have to see what all forces are acting on this body. Like what all contact surfaces are there, and the forces acting on the body. So now if you want to find the magnitude of these forces, you can equate it here. For example, for the block 1, you can see that there is no vertical or horizontal motion. Like I have stated that this entire setup is in rest. Okay, so you can see that this block vertical motion is not there. So the vertical forces, the net force in vertical direction is 0. That means N21 minus M1G, because they are opposite in direction, is equal to 0. That means N21 equal to M1G. So that is one equation. Now here in block 2, you can see that net force again in vertical direction. Sorry, there is no motion in vertical direction. So net force equal to 0. So that means N2S minus M2G plus F12 is equal to 0. So N2S equal to M2G plus F12. Okay. So another thing is, now you have to consider Newton's third law. So that is action-reaction pairs are equal and opposite in direction. equal in magnitude and opposite in direction. So you can see that N2S and FS2 are action reaction pair, and N21 and F12 are action reaction pair because of the contact that is happening between these two blocks and this block and surface. So that means by Newton's third law, N21 equal to F12 and N2S equal to Fs2. Can substitute it here. So here Fs2 equal to N2S, that is given. So N2S is here. So N2S and Fs2 we have taken, right? Okay. Here this F12 is what? N21. This F12 is N21. This N21 is given here. So that means M1G. So you can see that N2S equal to M2G plus M1G. Okay. So that is the total normal force given by the surface to the block N2S. Okay. And you can see the force exerted by these two blocks together on the surface is Fs2 is equal to N2S, that is equal to M2G plus M1G. You should see that there is no sign consideration here. Fs2 is actually minus N2S. Okay. So if you are considering sign, that is minus N2S, Fs2 equal to minus N2S, and here rest of it is correct, I guess. Okay. So sign is like this. Otherwise, magnitude wise, these two are equal. Okay. Now, another example, you can see on an inclined plane. Now, you will understand why I am saying that mg is not necessarily the normal reaction. So, here you can see that every block has downward acting force, downward in the sense towards the center of Earth. So that force is called the weight of the object, that is mg. Okay, you imagine this is a fixed inclined plane. So inclined plane. Okay, now you need to know what are the forces acting on this object. So you can see that this is the contact surface. Okay, so contact surface is like this. So always normal reaction is always perpendicular to the contact surface. So how the normal reaction will happen? It is perpendicular to the contact surface. Okay. So if you want to draw N, that will be like this. This is N. Okay. So N is like this. Mg is always acting downwards. Now, what else? So then this block is exerting some force on this surface that is also along the normal reaction, that is perpendicular to the surface, the contact surface. Okay. So you can take it as F. Okay. Now, if you want to know about the magnitude of the force, you should recall the vector resolution. So how to resolve a vector into its components? You can see that if this is theta, then okay, I'll draw the vectors here. So this is the horizontal surface. Okay, or we could see here, this is an inclined plane. This is a force mg that is acting downwards. This is theta. That means okay, one second. Okay. Okay. So this is along the plane and this is perpendicular to the plane. Okay. So we need to resolve this mg force along the plane, along the inclined plane and perpendicular to the inclined plane. So how to do that is, if this angle is theta, then if you consider two parallel lengths like this and transient like this, this angle is theta. So you can see that if this angle is theta, then this is also theta, right? Okay, this is 90 minus theta and this is theta. Okay. Okay. Wait. So you can see that this is mg. This is mg cos theta, and this is mg sine theta. So these are the two components. That means this F that is being applied on the surface by the block is equal to this mg cos theta. So F equal to mg cos theta, which is equal to minus n. You can see that these are the action-reaction pairs. So this is n, this is F. So F and n are equal and opposite in direction. So equal in magnitude and opposite in direction. So that means this, when you resolve this component of weight, which is along the inclined plane and perpendicular to the inclined plane, you can see the force exerted by the block is mg cos theta, which is this one, and that is equal to minus n. Now, if you want to see the force which is acting along the block, that is mg sine theta. Okay, so there is no reaction force because there is no surface to provide the reaction force. So this is the FBD. You can see. So the free body diagram of the object is like this. The block is like this. This is mg, and you have to see what is perpendicular to the surface and parallel to the surface. So parallel component is mg sine theta, and perpendicular component is mg cos theta, and there is a normal force. There's a normal force. So you can see that n equal to mg cos theta. Okay, you can, because there is no motion in the vertical direction. Vertical means the perpendicular direction to the inclined plane. There is no motion, so you can just equate this thing. Okay, and why something is sliding when you are keeping it on an inclined plane, you can explain it using this component. So if you are keeping an object like this on an object like this block on a surface of inclined plane, it will slide due to this force acting as the external force on this object. Now, if you want to see the FBD of this inclined plane, you can see that this F being this force is what this block is applying on the surface. So that can be taken as, so this is a surface. So perpendicular to the surface, F is being provided, that is equal to mg cos theta. That's it. So this is the free body diagrams of surface and block. Now, let's do a question. So imagine a block of 5 kg is kept on a smooth surface, and a force of 5 Newton is acting on this block. So we need to find the acceleration and normal reaction. So acceleration, how to find? First, we have to draw the FBD, right? So FBD is, imagine this is the block, 5 kg block. So this force mg is acting on the object. So you can see there's a mg, or 5 times. Let's take g equal to 10 meter per second square. So this is the weight of the block. Weight of the block is mg equal to 5 times 10 equal to 50 Newton. Okay. Now, so you can see this one. And then there is a reaction force by the surface on the body. So that reaction force, you have to draw it in the free body diagram. So that is the normal force. Okay. Now, another force is acting horizontal, which is the external force that we are giving. So that is 5 Newton. Okay. So these are the forces that are acting on this object. Now, to find acceleration, you have to imagine the horizontal direction. So, okay, in the horizontal direction, you can see that net force is equal to mass times acceleration. So this is from the second law of Newton. Net force is what? This is the net force, right? So net force in horizontal direction. There is no other force acting in the horizontal direction. So 5 Newton is equal to mass 5 kilogram times acceleration. So acceleration equal to 1 meter per second square. Okay. And what is the net normal reaction? Consider the vertical direction. Vertical direction, you can see that there is no motion in this direction. Okay. The block is not moving up or down. So there is no motion in vertical direction. So net force is equal to mass times acceleration. Acceleration equal to 0 because there is no motion at all. Velocity is also 0. Acceleration is also 0. So net force is what? You have to consider if you're taking N first, then mg is opposite. Or else if you're taking mg first, then you have to consider N as opposite. Any manner you can write. Okay. Finally, depending on the magnitude of the force, it will be turning out to be negative or positive. Here it is being equated to 0, so it doesn't matter. So n minus mg equal to 0 or mg minus n equal to 0. That means n equal to mg. Mg we have found to be 50 Newton. So normal reaction is equal to 50 Newton. Now, the next question. Okay. So there is two forces that is acting on this block. One is 5 Newton towards the right and 3 Newton towards the left. So this is push and pull that is happening. You should know. So you can see that it is unequal forces that is acting, and intuitively you can understand that since 5 Newton is greater than 3 Newton, so the direction of the motion will be along this direction of the larger force. Okay, this is a intuition, or the by observation we are saying this thing. Anyway, so we first we will be drawing a free body diagram. So what is the free body diagram here? So first, this 5 Newton is acting towards the right. Then 3 Newton is acting towards the left. Then there is this mg that is acting downwards, which is equal to 5 times 10. 10 is the gravity we are taking. So that is equal to 50 Newton. Then there is this normal force. Okay. So now we will equate it to find acceleration. So horizontal direction, we are considering acceleration, a motion of this block. So net force equal to mass times acceleration. Net force is what? 5 Newton minus 3 Newton, because it's opposite in direction, is equal to 5 times A. So you can see here, it's 2 Newton by 2 by 5 equal to A, 5 kg. Is equal to A equal to 2 by 5 meter per second square. Now for normal reaction, you have to equate the vertical direction. No motion, that means A equal to 0. So net force is mg minus n equal to 0. So mg equal to n, that means n equal to 50 Newton. So that is the next question. Now imagine something like this, where you have an angle. The force is applied at an angle to the object. So you have seen how to resolve the forces, right? So you can draw the free body diagram. So how to do that? So this is a force that is given, 10 Newton. So it is acting at an angle of 37 degree from horizontal. So you have to resolve this force into its component. So one is along the horizontal direction, and another one is along the vertical direction. So horizontal direction, you can see this is 10. Okay, 1 second. Okay. This is 10 cos 37 degree. This is 10 sine 37 degree. This is a very important result, that is sine 37 equal to 3 by 5 and sine 53, because 37 plus 53 equal to 90. So in that manner, so sine 37 and 53 angles are very well asked. So you have to remember this. And cos 37 is equal to sine. You can take it as sine 90 minus 53, which is equal to sorry. You have to take it like this. So sine 90 minus 37. So you know the complementary angle laws, right? So if you encounter sine 90 minus 37, That means it is 90 means you have to change sine to cosine. So it's cos and 37. Okay. So likewise, you can write it like this. So sine 90 minus 37 equal to sine 53, which is equal to 4 by 5. Okay. So cos 53 can be written as sine 90 minus 53, which is equal to sine, sine 37, which is equal to 3 by 5. So these angles you have to remember, okay, this number. So you can see that this is equal to 10 times cos 37 is 4 by 5. Okay, so that is equal to 8 Newton. And this one is along the vertical direction, 10 sine 37 equal to 3 by 5. So 10 into 3 by 5, which is equal to 6 Newton. Right. So this is how you resolve a vector into its components along some axis, like given axis. Okay. So you can draw it over once again. So if you take this as our block, so this is the given force, which is 10 Newton. So these are the result components. One is 8 Newton, the another one is 6 Newton. So you can see that the force, there is this one force which is acting, and there is this one force which is acting downwards, which is the mass of the object, mg. So mg is equal to 5 times 10 equal to 15 Newton. Okay. So in vertical direction, what all forces are there? Vertical direction, you can see that. And there is this normal force also that we haven't drawn, sorry. So normal force is also there due to the surface. Vertical direction, there is this 6 Newton. Okay, 6 Newton plus this N is the normal force, is equal to 50 Newton. So you can see that N is equal to 50 minus 6 equal to 44 Newton. Okay, so that is the normal reaction. And acceleration is due to the horizontal force. So horizontal forces, horizontal force is 8 Newton. So net force equal to 8 equal to mass times acceleration. Acceleration equal to 8 by 5 meter per second, which is equal to 1.6 meter per second square. So this is how you find. I hope you understood how to resolve the vectors, which is really important. By observation, you can understand, since you are like, this is like carrying something. For example, you are exerting a force to carry this block or pull this block from, you are pulling this block away from the surface, right? Like there is this toy cars are there where you will have a thread attached to it to pull this, right? So such a kind of arrangement you can imagine. So on the surface, instead of keeping it rested here, the entire weight of the object is not being exerted on the surface. You can see that, right? So that is the resulting weight that is being exerted by on the surface is this 44 Newton. So equivalent to that 44 Newton, the surface will provide a normal force. So you have found that to be 44 Newton here. And the pulling, if you're pulling it by 10 Newton, due to this angle of 37 degree, this horizontal force won't be equal to 10 Newton. So the motion will have an acceleration which is proportional to the horizontal force being exerted. So you can imagine, if the horizontal, this angle, this 10 Newton was acting horizontally, that means the angle here was 0, that means cos 0 equal to 1, and this 10 Newton was given, means the acceleration will be increasing, right? Since there is this angle of 37 degree, the acceleration is here, it was like 1.6 meter per second square. Imagine this angle to be 53 degree. It is like increasing, or 45 degree for instance. So then the force here will be proportionally like 10 times 1 by root 2, right? So cos 45 will come, that is 1 by root 2. So that will be lesser than 8 Newton. So the acceleration will also be lesser than 1.6. If it increased to 53, if it increased to 60, if it increased to 75, you can imagine that the horizontal component of the force will reduce proportionally, and the similar effect will be reflected on the acceleration also. And once it reaches 90 degree, there is no horizontal force, right? So you can see cos 90 equal to 0. So that means acceleration will be 0. So this whole 10 Newton will oppose the weight of the object. So it will be like the effective downward direction weight will be 50 minus 50 minus 10, which is equal to 40. So the normal reaction will be equal to 40 Newton. So that is a final, like we were talking about different angles at which this force was acting. Okay, I hope you have understood the concept of FBD, free body diagram. If not, we will be continuing this discussion in the next lectures also. So free body diagram is a very important concept in laws of motion, solving the problems related to laws of motion. So we will be looking at different models of questions, how to draw a free body diagram, and how to resolve the vectors, and how to calculate the acceleration or normal reaction due to the forces acting on a body. So we will be continuing this discussion in the next lecture. Thank you so much.